In this problem, it is not apparent from the standard viewing window whether the graph of the quadratic function intersects the x-axis once, twice, or not at all. Redraw the graph clearly to show the x-intercept, if any. State the window and identify the coordinates of any x-intercepts to the nearest hundredth. Well, let's go graph this. So I'll press my y equals, press my clear. You shouldn't have to do this, but I'm going to have to do an up arrow and unhighlight plot 1. And you do that by pressing enter on it. Let me do a zoom 6 to set it back to the standard viewing window. But let me clear that out. Okay, so if you press y equals, press clear to clear out wherever's not lined. Then we got x squared plus 1.5x plus 0.56, and I'm going to put 0 on y2. I'll talk more about that later, but I'm going to put 0 on y2. Now let me simply just push graph. And it doesn't look much different than what we got right here. Well, I'm going to zoom in. So I'm going to press my zoom button. And the best one I think to use is the zoom box. So I'm going to just go ahead and press enter on the first one. Now my little flashing plus is right here in the center. If I do my up arrow and left arrow, I want to put the flashing plus in the upper left hand corner where I want to draw a box. And that's good right there. So I press enter on that. And now I'm going to do a down arrow and right arrow. And what you should see is you should see it drawn a box. Now instead of sitting there clicking each one of those individually, you can just hold down on it and it'll very quickly go over. Now once you got a box around what you want to zoom in on, then you go ahead and you press your enter. Still not quite sure if we can see what's going on. It looks like it's coming down, touching at -1 and going back up. Pretty sure based upon these decimals right here, that's not true. So we could zoom in more. So I could do a zoom again and choose zoom box. And I'm going to move my mouse over maybe about right there. Press enter one time. Down arrow. Now I always like to, I'm going to hold down that button. I'm getting tired of clicking that. Part of the problem of holding it down is it'll go real fast sometimes, and sometimes you don't see it update on the emulator. But anyway, I press enter again. Still not quite sure what's going on, but it doesn't appear like it's going down below the x-axis, but that's okay. Let's work with what we got. Now I had you put 0 on y2 for a reason. If we do second trace and choose intersect, so push 5. We'll do enter on first curve, enter on second curve, and for a guess, I'm going to move my cursor over closer to this side. It doesn't need to be clear over there, but closer to that side, and then I'll press enter. It tells us the intersection is -0.8. So let me write that down. -0.8. Well, let's see if there's one over on this side. So now I'm going to do a second trace, choose intersect, enter on first curve, enter on second curve, and then I'm going to do a right arrow, moving it over closer over this way. Now, when you move your cursor, it'll find the answer closest to where your cursor is. So if it's coming down below the x-axis, maybe just a little bit, and come back up, this should find the one on the other side. And I'll simply press an enter once I get it over there. And I get -0.7. Now if I want to know what my window settings were, the problem is kind of implying that. You simply press your window button, and that'll tell you what your X-min and X-max is. So this is going from -1.7 to 0.2. on my x-axis. And for my y values, it's going from negative 0.4 to 0.6. Now to set your standard viewing window back, you do zoom and then you simply press 6. And that sets it back to your standard viewing window. Now I did not have to zoom at all in order to find those answers. If I simply did a second trace, chose intersect, enter on first curve, enter on second curve, and then for the guess, let me put in -1. You can actually type in what you think the guess is, and you want to choose an x value close to the answer you're trying to find. Then I press enter, and see how it comes back and gives us -0.8. And then I could have chose 0 on this side to see if there was another answer. So if I do second trace, choose intersect, enter, and I'll put 0 in. And that'd give me my other answer. There's another way of doing these. It's a little bit harder if you have a hard time seeing what's going on with your graph. It's a second trace, and we were using the intersect, but there's also the 0. So if I push there, choose that, it comes up and asks me for a left bound. I move my mouse to the left of where I think the answer is, and you press enter. And then I move it to the right of where I think the answer is, and then push enter. And then do enter on guess. I get the -0.7, but I wouldn't necessarily get the -0.8. It is very tricky if you cannot actually see what's going on to use the 0 function and get the correct answer. The intersect is your better way to go. Now let me show this by hand. Even though they're implying to use technology, I guess it wasn't f of x, was it? Okay. Y equals x squared plus 1.5x plus 0.56. And we're wanting to find the x-intercepts. Another way to find the x-intercepts is you can plug 0 in for y, and then you solve it. So we got 0 is equal to x squared plus 1.5x plus 0.56. Very doubtful this would actually factor, at least factor where we can see it. Although if we multiply everything by 100, we could probably see it. But we could use a quadratic formula. Now remember the quadratic formula. Whatever number is in front of your x squared is your 1. Whatever number is in front of your x is your is your b, so which is 1.5. I'll wake up here eventually. Whatever your number is at the end is your c. So again, a is what's before your x squared, b is what's before your x, and c is your number at the end. Our quadratic formula is x equals -b plus or minus square root of b squared minus 4ac all over 2a. So we're going to have, actually let me put parentheses in everywhere I have a variable before I plug in the numbers. And we said b was 1.5, so wherever I had a b, I'll put in 1.5. We said a was 1, so everywhere I had an a, I'll put in 1. And we said c was 0.56, so everywhere I had a c, I'll put in 0.56. So that gives us -1.5 plus or minus. And since I want a decimal answer anyway, I'm just going to type this square root in exactly as I see it. So come over to my calculator, I'll do a second mode to exit out of that. Then I'll do my square root, second x squared, and we got 1.5 squared minus 4. Even though it's trivial, I'll put beginning parentheses 1, closing parentheses, beginning parentheses, and 0.56. And closing parentheses, and then enter. Now that comes out nice. 0.1. And then 2 times 1 is 2. Now, since our radical disappeared, then we want to split it up into a plus version and a minus version. Because what that's saying is that says negative 1.5 plus 0.1 over 2, and it says negative 1.5 minus 0.1 over 2. I'm not very good at decimals, so let's see how I do on this. That's negative 1.4 divided by 2, which gives us negative 0.7. Looks familiar, doesn't it? That's our first answer. Over here, we got negative 1.5 minus 0.1. That's negative 1.6 divided by 2. And if I were to plug that in my calculator, I'd get negative 0.8. And that probably looks familiar. That's a first answer we came up with the intersect method. But anyway, that's how you can find those two answers, whether you're using technology or you're just simply using the quadratic formula.